I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology.
We are the students from second year IoT department. I'm Samiksha.
And myself, Abhinaya.
And this.
I'm Sanjeev. Myself, Saravakumar. And Mohammed.
Okay. Dear all, in this session we are going to discuss about standard distribution. In that we are going to see some discrete distribution. Right? What are all our DT5 stages?
Empathy.
Define.
Ideate. Prototype.
Ideate, then prototype,
Discrete.
test. So before entering into the discrete distribution, why should we study this discrete distributions? That is our empathy part. When we use discrete distribution, do you have any idea?
We can use it when the number of trials are finite, that is countable.
Yes. If the number of trial is either finite or countably infinite, means the random variable value means that time we can use a discrete distribution. So when will you use binomial distribution? Do you have any idea?
When the trial is infinite, uncountable.
Trial is finite. If it is finite now, that time we can go binomial distribution. When will you use Poisson?
When the number of trials are infinite.
Infinitive. And the number of trial is, it is must countable and countably infinite up to infinitive. 1, 2, 3, 4 up to infinitive. Like this now, we can go for Poisson distribution. When we use geometric distribution,
We use geometric distribution when the trials are from 1 to infinity.
trials start from 1 to infinity, but up to
Until we get the first
yes,
success.
until we get the first success, we repeat the trial in geometric distribution. So, binomial distribution, Poisson distribution, geometric distribution. These three things are coming under discrete distribution, right? So that's why we are going for these discrete distributions. So what is our ideate part? Anyone can write the mass function of binomial distribution? Yes.
So the mass function of the binomial distribution is NCx e power x q power n minus x, where n belongs to 0 to n.
No, x start from 0 to n. You write instead of n here, you write n here. So x start from 0 to n. Right? What is our n here?
Number
N
of
denotes
trials.
the number of trials. Okay. What is our small x denotes here? That
Number
denotes
of
the
choose.
number of success.
Success.
So what is the meaning of p here?
Probability of success.
Probability of success. And what is q here?
Probability of failure.
Probability of failure, right? So what is the mass function of Poisson distribution?
So the mass function of the Poisson distribution is e power minus lambda power x divided by x factorial, and x will be 0 to infinity.
0, 1 to infinity. Okay. So here the lambda value is greater than 0. Anyone can write the mass function of geometric distribution?
So it will be p power x minus 1 to q, where x is 1 to infinity.
Okay. So using this formula, we should find the probability of success values. Okay. So for example, when we tossing a coin 10 times, okay, 6 times we get head. So our random variable x denotes the number of heads. Means what is the probability of getting 6 value? Anyone can write. Using this mass function, you calculate the probability of getting 6. We repeat the trial up to 10. Okay.
So we are going to use this formula. Here the n is 10. So it becomes 10. C. X is the number of success. Since we get a head 6 times.
6 times.
We can substitute x as 6, and p is 1 by 2, as head is head probability of head is 1 by 2, x becomes 6, and q also 1 by 2 because the number of failure is probability of failure is 1 by 2. N 10 minus 6 will be 4. By this, if we substitute, should I need to calculate?
Yes, after calculating this value, we get the probability of x equal to 6 value, right? Okay, I am going to ask one more question. In number of monthly breakdowns of a computer will be considered as a random variable which follows the Poisson distribution. Average failure rate is 1.8 here. That means mean value is 1.8 here. So how will you calculate number of breakdowns in a month without breakdown? How will you calculate the value probability of x equal to 0? Anyone can write the value of this one? Can you try? So our mass function is e power minus lambda power x by x factorial. Our average rate of failure is lambda equal to 1.8. Substituting this value, what will you get?
Here.
Yes. Instead of lambda, you write 1.8. So it will e power
minus 1.8
minus 1.8
1.8
the
power x
power 6
Six,
0.
okay,
So
okay.
because now our number of breakdowns is 0 here. So lambda 1.8 the whole power 0 divided by
x factorial 0 factorial.
0 factorial. Very good. By simplification, we get e power minus 1.8 is the its average failure rate. That means without a breakdown, its probability will be e power minus 1.8. Okay. Thank you all. Thank you for your good cooperation. Thank you very much.
Thank you.